Welcome to the Explainer. Today, we're not just going to solve a few problems. We are building a mental toolkit. We're going to crack the code on some of these common, kind of tricky exam questions by learning a few really powerful shortcuts. Okay, let's just dive right in with our first challenge. How many numbers between 333 and 666 are divisible by 5? Now, you could sit there and count them one by one, 335, 340, 345, but come on, in an exam, time is everything. We absolutely need a faster way. And luckily for us, there is a much, much faster way. This is the first powerful tool we're going to put in our problem-solving toolkit. It's called the range formula. So this simple formula right here is the key to solving this thing in seconds. I know, it might look a little abstract, but let's break down what each little part means. It's actually incredibly straightforward once you see it in action. Okay, this is probably the most important step, so pay close attention. Let's define our terms. So D is the easy one. That's just 5, right? The number we're dividing by. But look really closely at N2 and N1. N2 is the last number in our range that's divisible by 5, which is 665, not 666. And N1 is the first number, which is 335, not 333. This is such a common mistake. You have to find the first and last numbers within the given range that actually fit the rule. So now we just plug those values right in. 665 minus 335, that gives us 330. Then we divide that by 5, which gets us to 66. And finally, and don't forget this part, that crucial last step is to add the 1, giving us our final answer. And there it is, 67. So there are exactly 67 numbers between 333 and 666 that are divisible by 5. No counting, no guesswork, just a clean, fast solution. Pretty cool, right? Now for our next problem. This one's about calendars, and it looks way more intimidating at first glance. But you might be surprised to see how that tool we just learned comes right back in to help us out. Right, a 58-year jump into the future. The big challenge here is accounting for all those years in between. We've got to figure out the total shift in the day of the week, and what makes that complicated is that, well, some of those years are leap years, and some of them are not. So the basic logic here is actually pretty simple. For every normal, non-leap year that goes by, the same date shifts forward by one day of the week. But if you cross a February 29th during that year, meaning it's a leap year, the date jumps forward by 2 days. So the big question is, how many leap years are there between 2023 and 2081? Well, a leap year is just a year that's divisible by 4. So what we're really looking for is the number of years divisible by 4 within this range. Does that sound a little familiar? And there it is. This is the perfect example of why we're building a toolkit. We can take our range formula and adapt it for this completely different looking problem. It's the exact same logic, we're just plugging in different numbers. So let's apply it. D, this time, is 4, because leap years are divisible by 4. N1 is 2024. That's the first leap year after 2023. And N2 is 2080, the last leap year right before 2081. We plug them in, do the math. 56 divided by 4 is 14, plus 1, and that gives us 15 leap years. Okay, so we knew there was a 58-year gap in total. But now, thanks to our formula, we have the exact breakdown. 15 of those years are leap years, which means the other 43 have to be non-leap years. And now we can figure out the total shift in days. We just multiply our 15 leap years by 2 days each and our 43 non-leap years by 1 day each. Add those two numbers together and we get a total forward shift of 73 days. So we need to find the day of the week 73 days after a Monday. Now, instead of counting all 73 days, here's another shortcut. We just divide 73 by 7. The important part isn't the 10 weeks. It's the remainder, which is 3. That means May 15th, 2081 is 3 days after Monday, so it's a Thursday. But wait, the question asks for May 12th, which is 3 days earlier. So we just go back 3 days from Thursday, which brings us right back to Monday. All right, let's switch gears completely. We've tackled numbers, we've tackled calendars. Now let's add a visual reasoning tool to our kit. These kinds of questions are all about applying one simple logical rule. This right here is the fundamental rule you just need to remember. A mirror image is a horizontal flip, so left becomes right, right becomes left. A water image is a vertical flip. Top becomes bottom, and bottom becomes top. That's really it. Okay, so let's apply that water image rule to this puzzle.
The best way to solve these is often by eliminating the options that break the rule instead of trying to picture the correct answer from scratch. Let's just walk through it. The rule for a water image is top becomes bottom. That means the hook that's at the bottom of the original object has to flip to the top. Well, options B and D both have the hook at the bottom, so they're out. Now remember, in a water image, left and right do not change. Option A incorrectly flips the object sideways. And just like that, there's only one possibility left. Option C.
So what have we added to our problem-solving toolkit today? Let's do a really quick recap of these powerful and, as you saw, super versatile techniques.
First, we've got the range formula, which is perfect for counting how many numbers in a big series are divisible by something. Second, we have the calendar method, which cleverly uses that same formula to break down those long date calculations. And third, our super simple visual logic rules. Mirrors flip left-right and water flips top-bottom.
This quote just perfectly captures what we've been doing today. We've taken questions that look really complicated on the surface and used simple, logical tools to make them, well, simple to solve.
And that really is the key takeaway. It isn't just about memorizing answers. It's about building a versatile toolkit of methods. Because once you have the right tools, any complex challenge starts to look solvable. Thanks for watching.